I'm Dr. J. Krishnaraj, Assistant Professor from the Department of Automobile Engineering, Hindustan College of Engineering and Technology, Valley Campus, Coimbatore. In this video lecture, I'm going to be brief about the topic in the field of automobile called automotive sensors. The overall outline of this presentation that are introduction to automotive electronics, automotive sensors and actuators, basic selection criteria for the sensors and actuators, different types of sensors that are being used for our automotive systems. Automotive electronics. Yes, over the past 30 years, we are supposed to be used in mechanical type of systems for our entire automobile actuations. So if it called to be as like a braking system or else an steering system, whatever it might be, we have only mechanical components that makes to possible of the vehicle motions. So even though if it is an fuel injection systems, there is no electronics and electrical systems placed in past years. So by the time they are used only a mechanical fuel injection pump and mechanical injectors that are being used for the entire operation of mobility. Afterwards, due to some lagging in the power and performance, safety in all the aspects, so we are supposed to be used in larger cubic capacity engines for producing in lesser power only. But at present now, they are keep on moving towards the electronics. So the mechanical systems are continue to be controlled with the electronic systems. So the electronic systems that are assisted to the mechanical components to improve its performance and its efficacy. So overall the electronical systems that assist the mechanical components to make and complete of operations, and we can able to modify its operations also, either making an advance or retardation of operations. So anything that must be possible within support of electrical systems and electronic systems. So these evaluations of microcontrollers, microprocessors and sensor technologies is allowing automobile industry to create complex systems that can provide higher level of vehicle control and safety. The overall goal of electronic and electrical systems is designed to balance the cost and development of the production systems. So the complex systems being like different of operations of working models. So while driving conditions, so everything, if it is in complex systems are being there, based on that the microcontrollers, microprocessors are introduced to our automobile systems with the help of sensors and actuators, so that are act smartly. At present, the future scenario that are AI enabled, artificial intelligence enabled automotive systems are in the future. So that takes a decision. So self decisions are taken by the AI, and the vehicle can be controlled by with the support of AI. In future also we are moving towards an autonomous system also. So with the support of artificial intelligence and machine learning, so that can improve our vehicle performance aspects in all those things. So we just move on to the autonomous of vehicles. So it is only possible with the help of microcontroller, microprocessor and embedded systems, that with the help of sensors and actuators. So here in this slide I am just showing the basic layout of automotive sensors, actuators and microprocessor and microcontrollers. So just looking on to this, so these are all the basic sensors. So here I am just showing of this. So all these sensors like a temperature sensor, pressure sensor, O2 sensor, all those things, it is having a different of operations based on the location and operations. It named as in different names. called to be as an, if you are looking into this pressure sensor, so the pressure sensor has a different of application. Fuel pressure sensor, oil pressure sensor, coolant pressure sensor, like that. Temperature sensor also, cabinet temperature, outside atmosphere temperature, engine temperature, and like in fuel temperature, coolant temperature, like different of its applications. Likewise, different kinds of sensors, all the sensors that reads the data and that delivers the signal to the ECU. So it is an ECU, engine control unit or engine control module. So these engine control unit and engine control module will get a basic function through this battery. So battery power is given for that, for the functional only. So these ECUs has a readable memory inside that, so that registered by the embedded codings like C, C++, Java, Python, like ECU codings are given for that, embedded codings are given. Based on that embedded coding, it receives the signal from ECU. That signals are signal processing. Then after it converts the signals from the sensors, either it is an analog or digital or in terms of power supply. All the signals which are converted into machine codes, zeros and ones. Based on this zeros and machine codes, zeros and ones, it is run by in the ECU programs. Based on that, it creates an output. These outputs are sent to the respective ECUs. Like actuators. So the actuators, it is having a different of actuators, like fuel injector is a kind of actuator, and like an valves, electronic valves are actuators. Fuel pump is a kind of actuator. High pressure pump, low pressure pump are there. Even automatic climate control is an actuator. Spark plug is an actuator. All those things are connected with the CAN network. So all the sensors, all the actuators and ECU is connected with the CAN, controlled area network. So all the sensors and actuators parallelly it receives the signals. So only the respective sensor and actuators will function. So how it functions based on that? So for example, ECU send a signal output to CAN network like 1011. So the 10 is given for fuel injector, and 11 is a remaining code for time, duration and injection pressure. So if the signal is given in the common CAN network, so all the actuators, even spark plug or like a fuel injection pump, fuel injector, valves, everything that receives parallelly, but 10 is code is respective for fuel injector. Then the fuel injector will recognize, and the remaining code 11 is given for time, duration and for pressure. For example, I will let you know that. So likewise, so the fuel injector will act smartly. So similar in the way, all the actuators will receive the code through CAN network. Only the respective code readable devices will act in this. So the automotive manufacturers are continuously increasing the use of electronic systems to improve the vehicle performance as well as safety as well as passenger comfort. Sensors and actuators are integrated with the automotive control computers, help to optimize vehicle performance while improve reliability as well as the durability. With the help of these things, so we can improve the reliability of the product also and the accuracy of the component also. So we can able to adjust, modify all those things, and we can get the accurate data with as much fast as we get. Actuators ECU, we must thoroughly know that what is to be measured. While selecting the sensors, what is going to be measured in this? So what is the measurable quantity or qualitative things we need to measure? Whether it is in quantitative data we need to measure or qualitative data. For example, quantity means O2 sensor that measures the quantity of the oxygen presence in the exhaust gases. Like qualitative data means like whether if you are taken into this automatic climate control, whether it reaches the respective demand of the temperature. So what is the comfort zone, what they are demanding, like passenger or driver. Likewise, we must be thorough before that what is the quantitative data or qualitative data. Then after we have to select a suitable sensor. So that sensors gets the power from the battery in different of power, either 5 volt or 10 volt or 12 volt, sometimes more than that also possible. Some sensors without of power, while it actuating, it produce the power, like knock sensors. Like different kinds of sensors are there, so you have to select the proper sensors. So all the sensors that gives and signals in different of like an options. Some of the sensors that gives an power output, some of the sensors gives an analog output, some gives an digital output. So all the signals, analog, digital, power output, that has to be sent to signal conditioning. These signal conditioning, so either any kind of signals, it conditioning the signal, that is, it improves the signal and convert into as an uniform signal output, analog to digital. So in terms of digital output, so that digital outputs in terms of zeros and ones, that is the machine code readable codes by the CPU, central processing unit. Based on that, the CPU will runs the embedded coding and it gets the output signals. The next is a selection criteria. So while selecting the sensors, so we must be thorough that previously what is to be measured, whether if it is in pressure or temperature or it's in special applications. So we must be thorough all those things. And afterwards, what is the magnitude of the particular sensor measurements and what is the range for the particular measurements, whether it is having a dynamic measurements or not, and the quantity of the measurements. Everything we have to be choose before the selection of the sensors, and the required resolution and accuracy. So it need a high accuracy of output for an engine management system. If you are looking to this air fuel mixture ratio measurements, so it needs a higher accuracy level and outmost the cost. So it must be in cost effective and environmental friendly the components, and whether if it is need any interface requirements. So interface in the sense of like an output quantity, whether voltage, current or resistance are needed there. Then sensitivity of the particular component is important thing. Then signal conditioning, so all the sensors that requires some signal conditioning, and analog to digital conversion requirements, everything it needed. So while selecting the operational parameters, so the sensors, while selecting the sensors, the operational parameters like the first thing is sensitivity of the particular component. So how sensibly it measures the measurements. The next is an accuracy of the particular component. Even if it is on temperature, if 0.1 degree Celsius changes in the temperature, so it needs to measure the accurate level of measuring the temperatures. Like if it is an automatic climate control, each and every degree Celsius it needs to measure. It needs a high accuracy resolutions. Then repeatability of the particular measurements. The very good example for the repeatability is like a wheel speed sensor. So it produces an repeatable signals. Even if it is in constant speed, it produces and how repeatable signals it produces. Then power requirement of the sensors. Some of the sensors require an DC power, some AC powers it works. Some of them work less than 12 volt power supply, and some of them more than 12 volt power supply is required. For that, stepping up actions are required. And in the special case, some of sensors that doesn't require for the working. The very good example is knock sensors. So while the engine is vibrating, from that vibration it produces the power volt. That power is developed signal processing, signal conditioning, then after it will be given for the ECU. So for those kind of sensors that doesn't require any power supply for its working. The next is a process requirement. The process requirement, so like interfacing. After producing the signals, it requires any process, and on the other hand, the process requirements while making the function of the sensors, it needs an process. So like the very good example is O2 sensor, lambda sensor. So for working of the lambda sensor, previously it needs an process like heating the sensors up to 200 degrees Celsius. So the lambda sensor starts to work above 200 degrees Celsius. So when the vehicle is in cold region or the engine is started initially, by the time the lambda sensors doesn't work. So by the time it produces the emission. To avoid this, initially it needs a process to heating up these elements. Then self-diagnostic requirement. On this self-diagnostic requirements, so of course the mobility, it has a vibrational harshness and temperatures, everything that plays. Due to this, the error codes will be formed. So it has the capability to self-diagnostic it functions. Then reliability of the particular component. Reliability is a very important parameter because the sensors need to be work in different of conditions, different of operational modes. So it must be a reliable one. It needs to withstand the life parameter. Based on that only the manufacturer can able to give the warranty guarantee in all the aspects. Then next thing is weight of this particular component. So it must be lesser in the weight so that we can able to provide a power to weight ratio also. Then range of the particular thing on the range. So for example, if you are taken an example of temperature sensors, we have two options like thermocouple and thermistor. So thermistor can able to measure the temperature up to 100 degrees Celsius. So that is used for like a measurement of fuel temperature. But if you wanted to measure the exhaust gas temperature, combustion temperature, so the range of particular thermistor is too low, for which we supposed to be go for an thermocouples. So the thermocouples can capable of measure the combustion temperature. So it is a very good example. Then size of particular thing. So it must be a minimal of size to accommodate the space, and it measures. Of course, the last one is cost. So even if all the consideration is considered, so the cost must be a minimal one, then only so in the market the particular product can able to succeed. So all those things, so which gives then output signal specifications. So based on that, the output signals must be varied. So I'm just here showing this variable resistance sensor. So it is an one type of VR sensor, or like in a potentiometer. It is otherwise called to be as a potentiometer. So on this potentiometer is used for the varying resistance. So if the resistance value are varied, accordance to with that, the output also varied. So that these sensors are mainly used for sensing large change in positions. These sensors are used for like in throttle position measurements, accelerator pedal position, and like in brake pedal positions, all those things which can capable of measuring this. So these positions like an accelerator pedal or brake pedal or throttle positions has and varying the large change in positions. So for which these potentiometers are used. These potentiometer is just like an fan regulators. If you are changing the positions, either it adding the resistance or decreasing the resistance. So the supply voltage is given for this sensors, or 5 volt DC power supply is given for this. So 5 volt DC power supply is enough for functioning the sensors. So the wiper is driven by the throttle shaft, thus the voltage from the wiper's contact with the proportional to the throttle position. The throttle potentiometer is used to indicate the rate of change of throttle position, informing to use to implicating the enrichment of overrun, the fuel cutoff, or these functions. So the function of the throttle position sensor. So it is the schematic cut section model of the potentiometer or especially throttle position sensor. So on which throttle position sensor, on the back side it is having a camshaft. So this camshaft is directly connected with the throttle valve, or it is in the application of acceleration pedal or brake pedal. So on the other hand, it is having a cam lobe. So these cam lobe has varying the contact positions. So these contact positions is directly contact over these filaments. You can look into this right hand side. So it is the back side of the sensor. It is having the filaments. So these filaments having varying resistance value. So these resistance are read by these filaments. So these filaments can take in the output of the values. So these output resistance values are taken out from this. So on the first thing is, so it is the electrical connection from which that, so input signal and output signals are taken. So the input is 5 volt DC power supply is given, and the output is taken out from the based on the resistance value. So the function of these variable resistance sensor. So initially, as per the manufacturer's information, so while starting the engine, we are not supposed to give any acceleration. So by the time or in the vehicle is in idle condition, we are not giving any acceleration. So how the machine can understand that whether the engine is running in idle or lean mixture, rich mixture? So because it is an electronics, right? So on this electronics part, so we need to give some signal to the ECU. So for which idle contact are provided. It is nothing but it is a contact breaker. So while in the idle condition, we are not giving any acceleration. So these cam lobes will compress this contact breaker. So what happens? The 5 volt DC power supply is directly given to this contact breaker, and again the 5 volt DC is directly given as an output. So which means that, so the ECU can recognizing that there is no acceleration, so idling is required for that. And while pressing the acceleration pedal, what happens? These cam loops will start to angularly move. So while moving angularly, it adding or decreasing the resistance value over these filaments. So you can look into this filaments, it is having a varying resistance value. So based on this resistance, so the 5 volt power supply is given to this cam lobes. So what happens? Depending upon the resistance, so these contact points will where it located the resistance. For example, the resistance value is 1 ohm means, so 5 volt is given. So afterwards the resistance, either it must be in like in 4 volt DC power supply is output is we are getting. So based on this output signal, so the EC can able to easily recognize that. So starting from 0.1 volt to 5 volt DC, so the output must be varied. And the last one is full load contact breaker. So on this full load contact breaker is nothing but, even though if you are giving a full throttle, the engine is demanding full load enrichment. So by the time full load enrichment is demanding on how the engine can able to understand these contact breakers will slide over the cam. On the end of this cam, it has a raising position. These raising position will tends to make contact these contact breakers. So by the time these contact breakers will gives the signal output. Once the signal output is receiving from this contact breaker, then the machine can able to understand that the driver is demanding full load enrichment, like an upclimbing or overloading. In these conditions, these full load contact breakers will make contact. So only pressing full acceleration, then only the full load enrichments are working. The application of the sensors. So the applications are like an accelerator pedal or brake pedal or throttle position. So these are all some of the applications of the sensors. So the location is like an engine management or the passenger compartment. So the function is registering the driver's wishes, demanding power, torque, whatever it might be. So it must be installed in the engine compartment or the passenger compartment. So the sensing principle is Hall effect or the potentiometers. The supply voltage is 5 volt and the output voltage must be varied from 0 to 5 volt. So the measuring range specifically from 40 mm to 80 mm. The temperature range is minus 40 degrees Celsius to 80 degrees Celsius. So it gives an signal output as an analog signal. So it needs an post processing of signal processing.